Hello, my students in grade 8. We are starting a new year, and in September, in mathematics, we will be revising 3 important lessons we learned together in grade 7. In grade 7, we talked about signed numbers, addition and subtraction, also signed numbers, multiplication and division. The last lesson is powers. In these lessons together, we learned important concepts or rules. So now we are revising these concepts. Concept number 1 talks about signed numbers. Which numbers do we call them signed numbers? Of course, signed numbers are all positive and negative numbers. A positive number always is preceded by a plus, for example, +9 +5. A negative number is preceded by a minus, -2, -5.8. As you can see here, 0 without a sign, of course. 0 is the only number which is not considered positive nor negative. -3/8 is a negative number written as a fraction. 5/6 is a positive number written as a fraction. Why did I consider it as positive? Since a positive number can be written without the plus sign or with the plus sign, as you like. So any number you see having no sign is considered as positive. Also, we have the opposite of a signed number. Always in signed numbers, any negative number has an opposite positive number, and any positive number has an opposite negative number. For example, opposite of -7 is 7 or +7. Opposite of +4 is -4. Also, we will be revising addition of signed numbers. If we have two signed numbers added together, they might be having same sign, a positive number added to a positive number, or a negative number added to a negative number. If we are adding two positive numbers, our answer will have a positive sign and we add both numbers. If we are adding two negative numbers, our answer will be negative. Also, we add both numbers. For example, +3 +15, both are positive, so my answer will be positive, and I add 3 + 15 is 18. I'm adding a -10 plus a -3, both are negative, and so my answer will be negative, and I add 10 plus 3 is 13. I might also be adding signed numbers having different signs. A negative number added to a positive number, or a positive number added to a negative number. Here, I will take the sign of the greatest to my answer and I subtract both numbers. -7 plus +10. I'm adding a negative number with a positive number. I ask who's the greatest or who's the biggest number, 7 or 10? Of course, 10 is the greatest number. Its sign is positive, so my answer will be positive. I can write it or leave it aside. Then I say 10 minus 7 is 3. We have an important rule, which is if we are adding two opposite numbers, their answer is always 0. For example, if I'm adding a -10 to a +10, the answer will be always 0. Now, the next concept talks about subtraction of signed numbers. If I'm subtracting a signed number from another signed number, number 1 minus number 2, what do? I keep number 1 as it is. I change subtraction to addition. Then I find the opposite of the second number. For example, -3 minus -10. I write -3. I change the subtraction into addition. And -10, its opposite is +10. Now I go back to addition. I'm adding a negative number with a positive number. Who's the greatest? Of course, 10. Its answer is positive, so my answer will be positive. And 10 minus 3 is 7. Now, multiplication of signed numbers. When you are multiplying two signed numbers, this means number 1 times number 2. Number 1 has a sign and number 2 has a sign. A positive number times a positive number is always positive. A negative times a negative is positive. So if you are multiplying same signs, always your answer will be positive. If you are multiplying different signs, your answer will be negative. Of course, after multiplying the signs, you multiply the numbers. Positive 3 times positive 10, I say positive times positive is positive. 3 times 2 is 6. Positive 2 times negative 7, positive times negative is negative, and 2 times 7 is 14. Now we move to division of signed numbers. Division can be written in both ways. It can be written with the division sign in between or as a fraction. Positive over positive or negative over negative. I'm dividing same signs also. My answer will be positive and I divide the numbers. For example, I'll give you an example. A negative 20 over negative 5. Negative over negative is positive. 20 over 5 is 4. If we are dividing numbers having different signs, negative number over a positive number, my answer will be negative, and positive over negative, my answer is negative. I will also give you an example. Positive 28 divided by negative 4. A positive over negative is negative. 28 over 4, the answer is 7. Now we move to our next lesson, which is powers. What do I mean in math when I say power? In math, we have an expression or a numerical sentence in which we add, subtract, multiply, whatever. Always, whenever we have an expression with repeated multiplication, we are multiplying the same number by itself many times. This can be written in power form. What is the power form or power notation? It's written as a to the power n, a number to the power n. How did I get this? I am multiplying the same number by itself many times. So I ask, what is the number multiplied many times or repeated in multiplication? It's a. How many times is it repeated? How many times I'm multiplying it? N times. For example, 5 cubed means I am multiplying 5 by itself how many times? 3 times as the exponent. In our lesson powers, we learned important rules of exponents or rules of powers. Any number to the power 0 always gives you 1. And any number to the power 1 always gives you the number itself. 1 to the power n always is 1. Let me give you examples. For example, 19 to the power 0, any number to the power 0, always your answer is 1. 11 to the power 1 is 11. Why? As if I'm multiplying 11 by itself one time, so it's 11. 10 to the power 1, also it's 10, gives me the number itself. 1 to the power 75, as if I'm multiplying 1 by itself 75 times, it also gives me 1. Now, the rule of powers, a to the power n times a to the power m. I'm multiplying two numbers having same base, different exponents. Also, I want to remind you of something. A to the power n, a is called the base and n is called the exponent. So here I'm multiplying two powers having the same base, different exponents. In my answer, I keep the base and I add both exponents. For example, 7 to the power 4 times 7 to the power 8. So I keep the base 7 and I add 4 plus 8 is 12. The second rule, a over b, all of it to the power n. I have a fraction to the same exponent. This exponent, as you can see here inside the parentheses, all the fraction is between the parentheses. So the exponent outside is given to every term inside the parentheses in the fraction. N is given to a, so I write an over. N is given to b over bn. 11 over 6, all of it to the power 4. So the exponent 4 is given to 11. It becomes 11 to the power 4. And the exponent 4 is given to 6, so it's written 6 to the power 4. The next rule is called the rule power of power. We have the same base with two powers. So I keep the base in my answer and I multiply both exponents. 5 to the power 3, all of it to the power 7 is 5 to the power 21. I multiply 3 times 7 is 21. The last rule, we are multiplying two different bases to the same exponent. This exponent outside, whenever you have times inside, this exponent can be given to the first term and the second term. So a to the power n times b to the power n. We cannot apply this if we have addition or subtraction inside. This is also only we apply it whenever we have multiplication inside the parentheses. Now, the last rule we learned last year, if we have a fraction, in the numerator we have a to the power n, and in the denominator over a to the power m. As you can see in this fraction, we are dividing two powers having the same base, different exponents. So this is written a to the power, here, a to the power n minus m, n minus m. So we keep the base and we subtract the exponents n minus m. For example, 7 to the power 9 over 7 to the power 5. We keep the base 7 and 9 minus 5 is 4. Finally, we will have something called the powers of 10. Powers of 10 are the powers that have base 10. For example, 10 to the power 5, the base is 10. 10 to the power 7, the base is 10. Always down here, the base will be 10, whatever the exponent is. To calculate a power of 10, we always write the 1 in the 10 and we add x zeros as the exponent. For example, if I want to calculate the value of 10 to the power 6, since it's a power of 10, from the base I take the 1 and I add 6 zeros as the exponent. All the rules of powers I talked about above also apply to powers of 10. So these are the important concepts I want to revise with you. I want you to watch this video well, and please, if you have any answer, don't hesitate to ask me. Thank you.